Vercel. So many of us use it every single day. It's a cornerstone of the modern web where we build and deploy our apps. But in April 2024, that foundation got a serious shakeup from a major security incident. So what really happened? Let's dig in.
On April 19th, this notice went out from Vercel, and yeah, it was a bombshell. It confirmed a breach, and you better believe that sent shockwaves through the entire developer community. Suddenly, teams everywhere were scrambling, asking themselves, how exposed are we?
And that really is the million-dollar question, isn't it? That's what we're going to unpack today. We're going to do a bit of a forensic investigation here, looking past the what to get to the why. We'll uncover the subtle but absolutely critical architectural choices that let one single compromised account spiral into this massive supply chain incident.
Okay, first things first. Let's talk about the immediate impact. When an attacker got inside Vercel's systems, what was actually at risk, and why did this send alarm bells ringing all across the industry?
Well, the attackers basically hit the jackpot. They got their hands on a treasure trove of developer secrets. And think about what that means. We're talking about customer environment variables that weren't marked as sensitive. That includes API keys, database URLs, signing keys, deployment tokens, literally the keys to the kingdom for countless applications and services. And on top of that, they grabbed the records for 580 Vercel employees, giving them a perfect internal map. And this is where it gets really, really scary, especially if you're in the Web3 and crypto world. See, tons of dApps, decentralized applications, host their front ends on Vercel. If an attacker can get the hosting layer secrets, they could quietly inject malicious code into the user interface. This completely bypasses all the on-chain security to trick users into signing bad transactions and draining their wallets. It created this hidden and frankly terrifying new attack vector.
So how in the world did they pull this off? Let's put on our detective hats and follow the breadcrumbs. We're going to trace the attacker's path, step by step, to see how they got from a small third-party tool right into the very heart of Vercel.
This timeline is just wild. The attack actually started 2 whole months before Vercel even knew something was wrong. Way back in February, an employee at a totally different company, an AI tool provider called Context.ai, got hit with info-stealer malware. That's nasty stuff designed specifically to steal credentials. It wasn't until mid-April that the attacker took those stolen credentials and used them to pivot right into Vercel's systems.
So here's the 4-step playbook they used. First, they compromised the OAuth app belonging to Context.ai. Second, they used that access to hijack the Google account of a Vercel employee who had authorized that tool. Third, now that they were inside as a trusted employee, they moved laterally into Vercel's core systems. And finally, the grand prize, they started pulling out all those customer secrets that weren't properly locked down. A classic supply chain attack.
And that right there brings us to the real heart of the issue. A critical architectural decision inside Vercel that turned what could have been a contained intrusion into a massive, sprawling data breach. This is where a seemingly tiny design choice had enormous security consequences.
Okay, you have to see this, because this is the whole story. Vercel had 2 ways to store secrets. The sensitive option was basically Fort Knox. It was encrypted and unreadable by internal systems. But it was opt-in. You had to go out of your way to enable it. The default setting for every single variable was non-sensitive, which meant it was stored unencrypted at rest. That single choice, making security an extra step instead of the default, left a huge, gaping hole for attackers.
This comment from Hacker News just nails the frustration the community felt. It's not just about Vercel, right? It's about a bigger, industry-wide problem where sometimes security feels like an afterthought. Everyone could see that an opt-in security model was just a recipe for disaster. It wasn't a matter of if it would be exploited, but when.
So we know why the damage was so bad. The vault was basically unlocked. But how did the thief even get into the bank in the first place? Let's zoom in on that initial entry point, because it exposes another architectural flaw, this time in how Vercel managed identity and access.
The key piece of tech here is something called OAuth. You use it all the time, even if you don't know the name. You know when a website says log in with Google or sign in with GitHub? That's OAuth. It's just a standard that lets you grant a third-party app limited permissions to act on your behalf, all without you ever having to share your actual password.
And here it is. This is the digital fingerprint of the malicious application. Vercel shared this as called an indicator of compromise, or IOC, so that other companies could check their own logs to see if they'd also been targeted by the same bad actor. This makes the abstract idea of an OAuth attack very, very real.
So here's exactly how it went down. It started when a Vercel employee granted allow all permissions to that context AI tool. Now critically, Vercel's own internal Google Workspace setup didn't block or even flag these overly broad permissions. So when the attacker compromised the tool, they inherited that golden ticket. They now had a trusted side entrance that let them waltz right past all of Vercel's normal perimeter defenses.
All right, so what can we all learn from this mess? In this last section, let's turn Vercel's painful experience into a set of clear, actionable lessons you can take back and apply to your own architecture, your own projects, starting right now.
Here's your new security checklist. Rule 1, and this is non-negotiable. Encrypt all secrets at rest, always. Rule 2, security has to be the default setting. Treat every credential as sensitive from the get-go. Rule 3, routinely audit all your third-party OAuth grants. With all the new AI tools popping up, this is more important than ever. Rule 4, your CI/CD pipeline is a prime target for attackers, so lock it down hard. And finally, Rule 5, ditch those long-lived API keys. Use short-lived temporary credentials wherever you possibly can.
And really, that brings us to the one big question you need to go back and ask your own team. Is your security opt-in, an afterthought, something your developers have to remember to enable? Or is it on by default, baked into the very fabric of your architecture from day one? Because as Vercel learned the hard way, the answer to that simple question can mean the difference between a close call and a catastrophe.